let G be finite and A a subgroup of G. We are in part B. Suppose P is prime and P divides the index of A in G, and A is a P group. Then P divides the index of A in its normalizer. So let A have cardinality, P alpha, since it's a P group. And assume that P divides the index of A in G. So, given G and G, we have two cases. Case 1, GA is not invariant under left multiplication by A. So we could just say let A act on GA, that should be G mod A. And here we mean left multiplication by A. If GA is not invariant under left multiplication, then what? Well, to be invariant, it means that we have, in this case we do not have, that for all A in A acting on GA is equal to GA. That is, it just takes GA to GA. Then, by the orbit stabilizer theorem, we have the orbit of GA has size of A over the stabilizer in A of GA. That the stabilizer of GA is precisely all A in A such that A dot GA is equal to GA. But we do not have that for all A that this holds, and therefore this set, the stabilizer, which we know to be a subgroup of A, is in fact a proper subgroup of A. So that means by Lagrange, first of all, the stabilizer's order must divide A, but furthermore, it must be now strictly less than A. So this forces that the orbit has size divisible by, or is some power of, p alpha, or some power of p, excuse me. So the orbit at GA has size power of p. Okay, that's case 1. What could case 2 be? Case 2 is GA is invariant under this action, in which case stabilizer must be the full group of A. So then the orbit must have size 1. Now, GA, that is the index of A and G, is the size of G mod A. Which is equal to by part A one times the number of invariant cosets, because each of those invariant cosets have size 1. And that is the index of A in its normalizer plus the sum from I equals 1 to L of P to the Li. Let's say to the K actually. That makes more sense. Where there are K many non-invariant classes, and P to the Li is the size of each of those classes. That way, this total sum will give us back the size of G mod A. But this sum is, well, clearly divisible by P. Since each term is divisible by P, the sum must be. And we assumed that P divides the cardinality of G mod A. Well, if P divides the cardinality of G mod A, then it must divide the index of A in its normalizer. So P divides the index of A in its normalizer, which is what we wanted.